Hello everybody, welcome again to another interesting video on quantitative aptitude from careerlight.com. Our topic for today is logarithms. And as all of you know, this is again a very important topic when it comes to your entrance exams and placement tests also. But a lot of students are actually confused about this topic. In today's video, we are going to solve all your confusions and make this topic a very interesting topic and easy to solve topic for you. Okay, so let's begin. Now see, before we can actually begin with the questions here, it is very important to get some basics right of this chapter. Okay, and the first thing that we need to discuss here is exponents. So all of you know that if I write something in the form of a to the power of m is equal to x, this is exponents, where a is the base, m is the power that I am raising it to, and x is the final outcome. This is something like 3 square is equal to 9 or 5 square is equal to 25. This is the same form, right? 3 is the base here, 5 is the base here, right? So now this question is easy. This is easy till here. But if I ask you the question other way around, for example, I asked you 5, I raise it to some power x and the final outcome is 25. What is the value of x? You'll quickly say 2. X is equal to 2 for you. I said 7 to the power something is equal to 49. Tell me what is the value of x? You'll quickly say x is equal to 2 because all of you can remember it very easily, right? But just for a moment, imagine the numbers getting bigger or the powers getting bigger. Okay. For example, if I had a number like 1728, power something is equal to y. Now if I ask you the same question, what is the value of x? It will get difficult for you. And this is where logarithms come into picture, right? So logs are written in the form of log x to the base a. See here carefully. The base is again a here, okay? So log x to the base a is equal to m. This is how I write it to be, okay? So exponents can be converted into logs and logs can be converted into exponents. And this conversion, if you understand that properly, this chapter becomes super simple for you, okay? And I'm going to teach it to you in a very easy manner. Let's learn. Okay, so now the way, the method or whatever you may call it to be, to convert an exponent to a log, I call it just swap. Okay, in a moment I'll just tell you why I call it just swap. But for the moment, just remember these two words because these are the two words that are going to be a key for the whole chapter. Okay, now let us come to the exponent part here. A to the power m is equal to x. We just saw that a is the base here, right? Now for a moment, look at the logarithmic part. Okay, how do I write it? Log x to the base a is equal to m. Just notice that a is the base here also. So if I convert this exponent to this log, right, my base doesn't change. My base doesn't change. Okay, this is the first thing that is extremely important to know. Now what happens? What actually happens is, if you notice the exponent part, notice that x here lies to the right hand side of the equal to sign, right? While m, the power, actually lies to the left hand side of the equal to sign, right? Coming to the logarithmic part, note that the positions get interchanged now. M now has come to the RHS side while X has gone to the LHS side of the equal to sign. So actually X and M are swapping their positions with respect to the equal to sign. Okay, let me explain it to you in a more better way. Okay, a to the power m is equal to x. Now I want to write it as a log. So I write log. My base stays the same. A was the base. So here also a is my base and this is the equal to sign. X comes here and m goes here, right? This m goes this side, this x comes this side, right? Is it easier now? They are just swapping their positions. X and m are just swapping their positions. Okay, let's learn with some examples now. So my example number 1 here says 10 square is equal to 100. Now I want to write it in the log form. How will I do that? I'll write log and we know that base stays the same. So what is the base here in 10 square? The base is 10. So my base stays 10, right? Now I put the equal to sign here. Something comes on the LHS side and something comes on the RHS side. LHS, earlier it was 2, so 2 exchanges the position with 100 with respect to equal to, so 2 goes on the RHS and 100 comes on the LHS. They just swap their positions, they just exchange their positions and the answer becomes log 100 to the base 10 is equal to 2. Now let us see example number 2. 10 to the power 3 is equal to 1000. How do I write it as a log? Log, what is the base? The base is 10 equal to sign, right? 1000 jumps and comes towards the left hand side and 3 jumps and goes towards the right hand side of the equal to. They just swap their positions. So the answer becomes log 1000 to the base 10 is equal to 3. Can you solve the third example now? 2 to the power 3 is equal to 8. How do I convert it? Just do it with me. Log, the base stays the same. So log something to the base 2 is equal to something. Okay. 8 comes towards this side. That is the LHS. And 3 goes towards the RHS of equal to sign. So log 8 to the base 2 is equal to 3 is how it turns out to be. Okay. They just swap their positions. What happens in the fourth case? 3 to the power minus 2 is equal to 1 by 9. So how do we do it? Log, the base stays the same. Log 3, log to the base something to the base 3. So now again 1 by 9 comes toward the left hand side and minus 2 goes towards the right hand side of the equal to sign. So log 1 by 9 to the base 3 is equal to minus 2 turns out to be my answer. Isn't it simple now? You just have to swap the positions of x and m and you can convert them into the log while the base maintains its position. The base stays the same in both the cases. Okay, now before you can actually begin solving the questions, it is very important to know certain properties of logs also. Because knowing these properties would mean that you will be able to answer many questions directly and otherwise also you'll require these properties to solve the questions. Okay, very, very important. Pay attention. Okay, so the first thing that you have to know here is if I take a log of 1, whatever may be the base, the value is always going to be 0. Okay, so for example, if I write log 1 to the base 2, my value will be 0. So even if I write log 1 to the base 3, my value is going to be 0. As simple as that. Okay. If my base and my number are same, if I write log a to the base a, the value is always going to be 1. Whatever may be the number. Okay. So if I have log 200 to the base 200, I just have to know the value is 1. Okay. Now, if you know this, see how easily you can answer your questions. The third thing you have to know here is the product rule. If I write log xy, where I have multiplied two numbers, log xy to the base a, I can also write it as log x plus log y, both to the base a. Pay attention to this. The base is a throughout. Okay. Now, there is a very important thing that you have to know here because this is a very, very common mistake that many students make. And it is that this is not equal to log x plus y, because this is a very common mistake that a lot of students make and they get the answers wrong. So just pay attention to this. Okay. The third thing you have to know here, the fourth thing rather, is the quotient rule, which means log of x by y to the base a is equal to log x to the base a minus log y. These are a lot of things which we do similarly in the exponents also, right? So if you can just relate it to exponents, you will find it easier. And again here also you have to remember that this is not equal to log x minus y. Okay, this is again a very common mistake that a lot of students make. See, I understand that you may find that this is quite a lot to remember, but don't worry at the moment. Don't think about remembering anything. Okay, just pay attention to what I'm telling you right now. When we practice this, when we apply all this, you will very easily be able to apply all this. At the moment, just pay attention to what I'm saying and just be attentive in the class. Okay, the next thing that we have to know here is log power, which means log of x to the power y. See, I have raised y to only x here. It is not the whole power, okay? And it is to the base a. I can write it as y comes out, okay? Y comes out and gets multiplied with log x to the base a. See how it will convert into actual questions. Let's see an example. So if I write log 2 to the power 3 to the base 10, I can write it as this 3 will come out. So 3 multiplied by log 2 to the base 10, right? This is the same thing, and knowing this will make it very easy for you to solve many questions. Okay. Now in this case the power was to x, but what happens if there is a power to the base and the number is without power? Okay. So in this case, this is the case of power is to the base. Okay. Log x to the base a power b. Okay. In this case, what happens is whenever the power is to the base, it comes out as 1 by b. What happened in the previous case? The number came out as it is. In this case, the number will come out with a inverse sign. Okay. So let us see with an example here also. Okay. Suppose I write log 10 to the power 2, log of 3 to the base 10 to the power 2. Can I write it as, now I can write it as, what will happen in this case? The power is to the base. So it is going to come out with 1 upon 2. It is going to come out as 1 upon 2. Rather than coming out as 2 as in the previous case, it will come out as 1 upon 2. It will come out as an inverse into log 3 to the base 10. Okay. Does it make sense to you? Very good. See, it is pretty simple as I'm telling you. Don't worry at the moment at all. Just follow what I'm saying. Okay. When we solve the questions, things will become very clear to you. Okay. Now, there will be many questions where you will be required to switch the base. Okay. So, if I am given log x to the base a, and I want that a and x should exchange their positions. How can I do it? I can simply write it as an inverse. Okay. So see how I've written it here. It becomes 1 upon, now it is log a to the base x, and you can switch the bases like this. Okay. So if I have something like log 2 to the base 10, it is equal to 1 upon, I want to switch the bases. How can I write it? I can write it as 1 upon log 10 to the base 2. This is the same thing. Okay. The last thing is changing the base altogether. See here. I have log x to the base a, but I want to change the base altogether. Okay. Now what do? I keep log x as it is. I divide it by log a, and in both the cases the base is the new base that I want, log c. Okay. And it can also be written as log x divided by log a. This is the same thing. Okay. Nothing is difficult here. You will not have to remember anything. Everything is pretty easy. We will just see how to apply all this that we have learnt in the actual questions. Okay. Let's go ahead. Okay. So now let's begin with some questions. We'll start with some basic questions and slowly move on to the difficult ones. Okay. So the first variety of question that we'll find here is find the value of log 25 to the base 5. Now this is pretty simple. Okay. We know that we can write 25 as 5 square. Do we know this? Yes, we all often know. So now this becomes log 5 square to the base 5, right? In our product rule, when we were learning the properties, we learnt this 2 will come out. So 2 multiplied by log 5 to the base 5. Now we already know that this is same base, same number. So the value is 1. We learnt in the properties. And this is 2. Okay. So the answer comes out to be 2. Easy, isn't it? Let's see the second part of this question. It is log 3 to the base 81. Now, how can you write 81? Can you write 81 as 3 to the power 4? Right? So, I can write this as log 3 to the base 3 power 4. Now, my power is actually in the base now. So, what happens here? Whenever the power is in the base, we learnt that it comes out as 1 upon the number. So 1 upon 4 it comes out to be, right? Multiplied by log 3 to the base 3, right? And we already know that whenever the number and the base are same, its value is 1. We have learnt it in the properties already. So the answer is 1 by 4. Again, very easy. All that you should try to do in such questions is see if you can get it somehow in this format where the base and the number are same and you can get the answer 1 there, right? See if that is possible. Okay, that will come with practice. Let's see the other parts. Let us solve the next part of the question. Log 1 upon 243 to the base root 7. Now let us try to solve this kind of a question in steps. So 1 upon 243. Can I write it as 1 upon 7 to the power 3, that is 7 cube, right? Because 7 sevens are 49, 49 sevens are 243. Yes, I can do that. So this is equal to 7 to the power minus 3. This is simple mathematics that all of us know. Let us mark this as 1. Okay. Square root of 7, all of us know, can be written as 7 to the power half. This is the second thing that we get from here. Okay. Can we place these two values in the log that we have on the top? Okay. So log 7 to the power minus 3 to the base 7 to the power half. Okay. This is what is the question actually. Okay. Now, can we find this value? Yes, we can find this value very easily now. We already know that what happens to this minus 3? It will jump out. It will come out and it will become minus 3 multiplied by log 7 to the base 7 to the power half. Okay. So now all of us know what happens when the power is to the base. Okay. In that case, it comes out with 1 upon the power, right? So minus 3 multiplied by 1 upon 1 by 2 log 7 to the base 7, right? So this is nothing but minus 3 multiplied by 2 and we know log 7 to the base 7 is nothing but 1. So the answer is here minus 6. Very easy. If you find it difficult, just pause the video here and take a good look. Okay. Moving on to the next part of the question. Okay. Log 1000 to the base 0.0001. Okay. Now again 1000 here. I can write it as 10 to the power 3. Very easy. 0.0001. I can write it as 1 upon 1, 2, 3, 4. Right. This is nothing but 1 upon 10 to the power 4, which I can also write as 10 to the power minus 4. This is simple mathematics that all of us know. Now I can just place these values in the question that I am given. Okay. Log 10 to the power 3 to the base 10 to the power minus 4. Okay. Now I know how to solve this very easily. I'll apply the properties, my product rule and my the base rule. Okay. So 3 comes out multiplied by what happens when the power is to the base? It comes with a inverse, right? 1 upon minus 4 log 10 to the base 10. This is what it is. So answer here is minus 3 by 4. And we know this value is 1. So the answer is minus 3 by 4. Again, see, very, very easy, very, very simple. All that you have to do is you have to know your simple mathematics properly and you have to apply it here along with the log properties. Right now we are going step by step. That is why all these questions are taking longer. Otherwise, once you have practiced sufficiently, you will quickly come to this step. And once you come to this step quickly, you will immediately write the answer. You will not have to do everything step by step. And this kind of a question will hardly take 20 to 25 seconds for you to solve. Okay, but you'll have to practice. Okay, let's try to solve the next part of the question now. Log 512 multiplied by 256 divided by 32. Everything to the base 2. Find its value. Now see, on the face of it, this may look to be a very difficult question to you. But trust me, it is a very, very easy question if you have practiced sufficiently, because it applies just very simple mathematics here. Okay. Now see, 32. How can I write it? I can write it as 2 to the power 5. How do I know it? I know it because I have practiced this and I use it every day in my practice. Okay. Now 256. How can I write it? I can write it as 2 to the power 8, and 512 I can write it as 2 to the power 9. Now let me place these values in the question given to me. Okay. Now that becomes log 2 to the power 9 multiplied by 2 to the power 8 divided by 2 to the power 5 and everything to the base 2. Now when I try to solve this, what do I get? I get log base is 2, 5, this becomes 3. Okay, 2 to the power 9 into 2 to the power 3. This is nothing but log 2 to the power 12 and the base 2. Now this is easy for me to solve because I know what is going to happen with this 12. This 12 is going to come out and get multiplied with log 2 to the base 2, right? What is the value of log 2 to the base 2? This is nothing but 1. I have learnt it in the properties. Now when it is multiplied with 12, what is the final outcome? The final outcome is 12, right? So the answer to this question is 12. See, very, very easy. All that I have to do is just practice sufficiently, right? So that I can recall the right things at the right time. Now coming to the next part of this question. And the next part of the question says log 0.0625 to the base 2. Find its value. Now see, 0.0625. How can I write it? Can I write it as 625 upon 1, 2, 3, 4. Just convert it into fractions, right? 25, 25 is 25, 400. Okay. Now if I try to further simplify it, I get 16. This is equal to 1 upon 16, right? And 1 upon 16 is what? 1 upon 2 to the power 4, right? 16 can be written as 2 to the power 4. So what is this question ultimately? This question is actually 1 upon 2 to the power 4, log of 1 upon 2 to the power 4 to the base 2. Now can I write this as log 2 to the 1 upon 2 to the power 4 can be written as 2 to the power minus 4, right? To the base 2. Now this can be written as the power is 2x. So minus 4 comes out, gets multiplied with log 2 to the base 2. This is nothing but minus 4 into 1. Log 2 to the base 2 is 1. So the answer is minus 4. See how easy it was. Nothing difficult here at all. Just that you have to see what is given to you and how can you get it in the right form. And that comes with practice. Question number 2. Find the value of y if log 25 upon 9 to the base y is equal to minus 2. Again, a very easy question to solve. All that you have to do is you have to get it back into the exponents form to solve this question easily. Okay. So now we sometime back learned the just swap method, right? There we learned that base in both the cases stays the same. So come to the log that is given to you. The base here given is y. So my base, if I try to convert into exponents, still remains y. And the next thing that we learned was the other two things, m and x, they just exchange their positions, they just swap their positions with respect to the equal to sign. So let us put the equal to sign. Minus 2 is on the RHS right now in the log that is given to me, right? So I'll bring it to the left hand side and the other thing other way around, right? So y to the power minus 2 is equal to 25 upon 9 is what I get in the exponents form, right? Now this is pretty simple. This is 1 upon y square is equal to 25 upon 9. So y square is equal to 9 upon 25, which means y is equal to 3 upon 5. Very, very easy. I have found the value of y for the question. Question number 3. If log u to the base 9 is equal to 36 and log v to the base 3 is equal to 6, what is the relation between u and v? Now see, this is again a very easy type of a question if you can convert your log into the exponent form. Okay, so now we know with the help of just swap method we can do it very easily. Let us see both the parts one by one. Okay, so log u to the base 9 is equal to 36. We know that base stays the same whether it is exponent or logs. We have learnt it with our just swap method. So my base here is 9. Okay, and the other two things, they exchange their sides, they swap their sides. So let us put the equal to sign here, and this is 9 to the power 36 is equal to u, isn't it? So this is equal to u is equal to 9 can be written as 3 square. 3 square to the power 36. This means this is equal to 3 to the power 72. This is what we have for the time being. Okay. Now let us move to the other log that is given to us. Okay. Again, log v to the base 3 is equal to 6. So I know if I want to convert it into exponent form also, my base stays the same. So base is 3 to the power other things. They exchange their positions with respect to equal to. So 3 to the power 6 is equal to v. This is what I have, right? So v is equal to 3 to the power 6, right? Now this 3 to the power 72. This can be written as 3 to the power 6 to the power 12, right? This 3 to the power 6 is what? 3 to the power 6 we just found is equal to v. So this is equal to v to the power 12, which is equal to u, and this is the relationship between the two, that is u and v. Now you will have to see what kind of an option is given to you, right? If it is given to you directly, you can say u is equal to v to the power 12, or if they have twisted it around, you can see it accordingly. Okay, but a very, very easy question to solve. You don't have to get scared at all. Question number 4. 10 log 10,000 divided by 5 log 100. So now in all the questions till now, we have always talked about a base. But notice that there is no base given in this question here. No base is given. What do we do in such cases? In such cases, whenever there is no base given, consider the base to be, consider base as 10, right? This is the most important thing that you have to remember. Okay, now let us begin to solve this question. It becomes very easy now. Okay, numerator is 10 log 10,000. Can I write it as 10 to the power 4? Yes, I can write it as 10 to the power 4 divided by 5 log. Can I write it as 10 square? 100 can be written as 10 square, right? So now from my power rule, what is it? 10, the 4 which is in the power at the moment comes in front, gets multiplied 4 into log. When there is no base given, I consider it to be 10. So log base 10, log of 10 divided by, again 2 is in the power right now, so it comes out, gets multiplied, and it becomes log, again nothing in the base, so the base becomes 10. Now this is quite easy, right? So this is equal to, we know 4 multiplied by log 10 to the base 10 is 1. We know this. Now in the denominator we just have log 10 to the base 10, so this is 1. So the answer here comes out to be 4. You see, we learnt in the properties that anything when the number and the base is same, the value becomes 1. So we are making use of the properties that we learnt about the logs. So that is why I had said it is very, very important that we pay attention to the properties because they find their application in the questions. Okay, let's move on to the next one. Question number 5. Log 2 multiplied by 2 to the power 2 multiplied by 2 cube goes up to 2 to the power 9 to the base 2. You have to find its value in this question. Okay. Now, from the face of it, this looks to be a difficult question definitely, but trust me, it is a very, very easy question. Let's see how to solve it. Okay. So now let us write this question again. Log base is 2. So 2 to the power 1 multiplied by 2 to the power 2 multiplied by 2 to the power 3 goes up to 2 to the power 9. Okay. Now, can I write this as, from exponents we know that this can be written as 2 to the power 1 plus 2 plus 3 goes on till 9, right? Now, what is this exponent? This 1 plus 2 plus 3 till 9. What is this? This is nothing but the sum of first n numbers. And we know that the sum of first n numbers is equal to n multiplied by n plus 1 by 2, right? So what is the value of n here? We have got 9 numbers, 9 terms. So 9 multiplied by 10 divided by 2. This is what? This is 90 upon 2, which is equal to 45. So the actual value of this power is 45. This can be written as log 2 to the power 45 to the base 2, right? Now, from our power rule, we know that this 45 will come out and get multiplied. 45 multiplied by log 2 to the base 2. Now, this is super simple for you. Log 2 to the base 2, you know, is 1. It gets multiplied by 45. So, the answer is 45. Looks to be a difficult question, but see how easy its answer is and how easy it is to solve it. All that you have to do is you have to apply the properties that you have learnt already. Okay, let's move on to the next question. Question number 6. In this type of a question, a lengthy expression is given to you and you are required to find its value. See, okay. Now, this is again a very, very popular type of a question in the exam. Although it looks difficult because the expression is quite lengthy, but if you go to solve it, it is very, very easy to solve. Okay, let's see how to do that. So for this type of a question, I would suggest that you start solving it from right hand side and go step by step. So let us first solve this much part of it. That is log 125 to the base 5. If you can solve this, the question would become easier. Okay. So now we can write this as 125 can be written as 5 cube to the base 5. So this becomes nothing but 3. Okay. Let's place the value 3 here. Now this means the question for you now becomes log base 2, log base 2, log 3 to the base 3. Now we know that if we solve the RHS again one step, this much is the part that we have to solve, and this is nothing but log 3 to the base 3, whose value we know is 1. Okay. So the question for you now becomes log 2, log to the base 2, log 1 to the base 2. And we know that the value of log 1 is always 0, whatever the base may be. Okay. So the question for you now becomes log 0 to the base 2 is what you have to actually find. And we know that the value of log 0, whatever the base may be, is undefined, right? Take it down somewhere in your notebook because this is going to be very, very useful to you. So this is undefined. The answer to this question is undefined. Okay, let's move on to the next question. Now, the next variety of questions that you find in this chapter is something like this. Question number 7. Find the value of log 15 upon 16 minus log 27 upon 45 plus log 48 divided by 75. Now, this variety of question expects you to apply the rules about logs that you have learned in the beginning. Okay, so they may expect you to apply just one rule or maybe a combination of rules or something like that. Okay, in this question here particularly, they are expecting you to apply the product rule and the quotient rule that we have learned at the beginning. Okay, so now what does the question say? The question says log 15 by 16, and now it is minus. Okay, so now as per the quotient rule, if it is x upon y, it becomes log x minus log y. Pay attention that the bases are same, and in our case, since there is no base given, it means base 10. Okay, so but we'll not take it right now. Let us just go on. Okay, so log 15 upon 16, and since I want to divide the second thing, I actually multiply it with the inverse. Okay, so I do it 45 upon 27, right, multiplied by the third thing is add, right. So this is the application of product rule, right. Log xy is equal to log x plus log y. This is the application of this rule. So I multiply it. 48 by 75 is what I do here. Okay, now can I solve this much part what I have in the bracket? Yes, I can do it easily. 16 3s are 48, 3 9s are 27, 9 5s are 45, 5 15s are 75, 15 cancel, and the ultimate value that I get from here is log 1. Okay, and we know that the value of log 1, whatever the base may be, is always 0. So ultimately the value of this expression, the final value of this expression comes out to be 0, nothing else. Okay, so just pay attention which of the rules is getting applied in particular question and go accordingly. Question number 8. Log 2 to the base 10 is equal to P. Log 7 to the base 10 is equal to Q. Find the value of log 28 to the base 5. Pay attention that the value that we have finally asked is to the base 5. Log 28 to the base 5, which is different from what is given to us. The given to us thing is the base 10. Okay. So now this kind of a question is again very popular. It's not difficult, but you have to pay attention because this type of a question expects you to apply three log rules that we have learned. The first one that needs you to apply is the product rule, quotient rule, and the change base, because ultimately the answer is in a different form. Okay, so these three are the rules that you need to apply. How to go ahead? Let's see. So what we are asked is log 28 to the base 5. Now can we write it as log 5? 28 can we write it as 4 into 7? Yes, we can write it as 4 7s are 28, right? So this is equal to log 4 to the base 5 plus log 7 to the base 5. How do we get this? We get this from our product rule, which says log x into y is equal to log x plus log y, provided their bases are same. Okay, now can we write this log 4 as log 2 square to the base 5? Yes, we can, because 4 is equal to 2 square plus log 7 to the base 5, right? So this is equal to 2 log 2 to the base 5 plus log 7 to the base 5. Now till here we have reached, but now whatever we are given is in the form of log base 10. Okay, and what we have here is base 5. We need to change the base here. So let's take a look at change base rule here. If I want to change the base from a, I can do it. Log x to the base a can be written as log x, and now my new base is c, divided by log a, the new base is c. Okay, so now since I am given everything in log base 10, so I'll try to convert it into base 10. So I will write it as this is equal to 2 log 2 base 10 divided by log 5 base 10, right? Plus log 7, what is the base? Base 10, because that is what we are given. And the denominator will be log 5 base 10. Now this makes my life a little simpler, okay? Because now I can put the values, at least in the numerators, okay? 2 log 2, log 2 to the base 10 we are given is p, divided by, I'm not given the value of log 5 to the base 10. So what I'll do, 5 can be written as 10 by 2, right? To the base 10, I'll do this. Now the value of log 7 to the base 10 is q, we are given in the question. Again, I don't know log 5 to the base 10, but I can write it as log 5 can be written as 10 by 2 to the base 10. Now, when I apply my quotient rule, what happens? I get 2p divided by log 10 to the base 10. Take a look at the quotient rule here. It says log x upon y is equal to log x minus log y, provided their bases are same. So we have the same base here. Again, coming back to the question, so we have got the same base here, 10, right? So log 10 to the base 10 minus log 2 to the base 10, right? This is my first part, plus q upon log, here again 10 to the base 10 minus log 2 upon 2 to the base 10. Okay. Now I know the values here. What do I know? 2p divided by log 10 to the base 10 is value 1, minus log 2 to the base 10 I am given is p, plus q as it is from the second term, divided by, again log 10 to the base 10 is 1, minus log 2 to the base 10 I am given is p. So ultimately this expression comes out to be 2p plus q divided by 1 minus p. Looks a little lengthy, but not at all difficult if you know how to apply these log rules properly. If you find it difficult, I would recommend that you pause the video here, take a good look before you move on. Okay. Now moving on to the next question. Question number 9. Log x square minus 6x plus 10 is equal to 0. Now see, in this variety of question, x is replaced altogether by an expression, and it is a quadratic expression, x square minus 6x plus 10. Okay. Now for this type of a question, let's see the right hand side first. This 0, it is equal to, we know that if we try to write it in the form of a log, we can write that log 1 is always 0, right? So let us write it as log 1. Now log x square minus 6x plus 10 is equal to log 1 actually, okay, which means x square minus 6x plus 10 is equal to 1, right? Now what is this? This is a quadratic equation that you have to solve. So this becomes x square minus 6x plus 9 is equal to 0. If we solve this quadratic equation, we get x square minus 3x plus 9 is equal to 0. So x minus 3 into x minus 3 is the answer here. So this is x is equal to 3. That is what we get from here. The value of x is 3 for this question. If you find it difficult anywhere, although it is not at all difficult, but if you are confused anywhere, just pause the video for a moment and take a look. All that we have done is we have equated it with log 1, because on the RHS we had 0 and we know that log 1 for any base is equal to 0, and this is the information that we have made use of. Moving on to the next one. Question number 10. If log 105 is equal to p, find the value of log 101 to the base 100 multiplied by log 102 to the base 101 going up to log 105 to the base 104. Now, if you look at the figures, definitely the question looks scary. But this is an extremely easy question, which just needs you to make an application of a rule that you have learnt initially by learning the chapter. Okay, and once you solve this question, you'll yourself see how easy the answer is. Okay, now the rule that we have learnt was in the change base thing. Okay, so log x to the base a can also be written as log x upon log a. Okay, this is just an application of this rule only. Okay, now see how it is. Log 101 to the base 100 can be written as, using this rule, log 101 upon log 100. I can write it like this, right? Similarly, I can write log 102 to the base 101 as log 102 upon log 101. I can do this, right? So now if you make use of this rule, see how easily you will be able to solve this question. Let us begin. Okay, so now whatever is given to me in the question, let me start writing it with the help of this new rule that we have learned here. Okay, so log 101 upon 100, log 101 to the base 100 can be written as log 101 upon log 100, right? Multiplied by, what am I given? Log, the next term is log 102 to the base 101, 102 to the base log 101. Let's keep going on now. Log 103 to the base 102 can be written as like this. Now go on to the next. Log 104 upon log 103 multiplied by log 105 divided by log 104. This is what is actually given to me in the question, and I have put it in my new form. Now, can I start cancelling something here? Yes, I can. Log 101 gets cancelled here, 2 gets cancelled here, 3 gets cancelled here, 4 gets cancelled here. So ultimately, what am I left with? I am left with log 105 upon log 100, right? Using the same rule that we applied earlier again, that I have written here in the box, I can write this as log 105 to the base 100. Can I write it like this? Yes, I can. So this is equal to log 100 can be written as 10 square, right? Log 105 to the base 10 square. Now I know that this power in the base goes inverse and gets multiplied. So 1 by 2 into log 105 to the base 10, right? Now what is given to me? I am given the value of log 105 as P, and since there is see, go to the question, log 105 is given to me as P, and since no base is given, I would assume it to be 10, right? So 1 upon 2 multiplied by P. This is what I get. So the answer ultimately is P by 2. The value of such a big expression is just P by 2. A very easy question, isn't it? If you find it confusing, I would recommend that you pause the video here, take a good look at the solution, and I'm sure you'll be good to go. Okay, let's move on. Question number 11. Log 11 is equal to A. Find the value of log 1 upon 110. So now see, we already know that 1 upon A can also be written as A to the power minus 1, right? This is an application of this and the product rule. Okay, how? Let's see. So log 1 upon 110, as we discussed, can be written as log 110 to the power minus 1, isn't it? So this is equal to minus 1 multiplied by log 110. This much we know already. This is equal to minus log 110 can be written as 11 into 10, right? And since there is no base given, so we will assume it to be 10, right? It is equal to minus log 11 to the base 10 plus log 10 to the base 10. This we know from the product rule. So this is equal to log 11 to the base 10 is given to us. It is given to us as a. So this becomes a, right? Minus sign here plus log 10 to the base 10 is 1. So this ultimately comes out to be minus of a plus 1. This is the value of log 1 upon 110, right? Isn't it easy? Let's move on to the next one. Okay, now the next variety of questions that you will find in this chapter would be if log 2 is equal to 0.3010. The value of log 2 is given to you here. You will be required to find the value of log 1024. See, these questions may look difficult to you because 1024 might seem to be a big number to you to solve, but these questions are extremely easy to solve. Okay, if you are able to simplify the previous sums that we did, if you are able to do them, this question is not going to be a problem for you. Okay, the only thing you will require is just in most of the cases the value of log 2 or log 3 or whichever log is required to be in use will be given to you, but just for the convenience sake, log 2 is equal to 0.3010, log 3 is equal to 0.4771. You can try to just keep this in your mind. Okay, so this question is log 1024, right? So we know that log 1024 can be written as 2 to the power 10. We have seen all these things earlier, right? So, and if we try to simplify this, this is simply log 10 log 2. The power has come in front and it has gotten multiplied with the log. Okay, there is no base given, so it means it is base 10, right? Now the value of log 2 is given to you, 0.3010. This is equal to nothing but 3.010 is the value of this number. Okay, quite a simple question, and most of the questions that you find would be quite simple. You will have to just apply the logics that you have learned till now. Okay, and if you are able to do that, these kind of questions should not be a problem for you. Okay, let's move on to the next thing. Okay, so now before we move on to the next type of questions, there is some very important basic that you need to know, and it is the characteristics and mantissa of a log. Okay, and this is something very important. You will find one or two questions based on this information. Okay, so whenever you take the log of a number, the answer you get is divided into two parts, right? One is, the first part is characteristic and the second part is mantissa. Okay, so if I write the log of say x and my answer is something like 1.234, something like this, then this 1, this is the characteristic here, and 0.234, this is the mantissa. Okay, let's talk about the characteristic first. So characteristic is something that you can calculate. Okay, and there is a way to find it out. Let's discuss that way here first. If the number that is given to you is greater than 1, the number whose log you are finding, if it is greater than 1, then to find the characteristic, you have to number of digits in the integral part minus 1. I'll just explain it to you with an example also below. For the moment, just see what I'm just telling you here. Okay, if the number is greater than 1, then the characteristic is number of digits in the integral part minus 1. And the second thing that you have to see here is, if the number is less than 1, in that case it is equal to, the characteristic is equal to, notice the minus sign here, minus of this minus here. Okay, minus of number of zeros immediately after the decimal point plus 1. Okay, so these are the two important things that you need to know to calculate the characteristic. Now let us see how does it actually apply in the real questions. Okay, So let us take an example here. If I am required to find the log of 7.23, okay, now I see that 7.23, the number is greater than 1 definitely, okay. So what applies here? My first rule would apply here in this case, okay. The number of digits in the integral part. The integral part is the part before the decimal point, okay. How many digits are there? Only one digit, that is 7 is here, okay. So how many digits are there? Number of digits in the integral part is 1 and minus 1. That is what you have to do, and that is what our rule number 1 says. If the number is greater than 1, in that case, in characteristic, if you want to find the characteristic, then it is number of digits in the integral part minus 1. This is equal to 0. So the characteristic of the log of this number is equal to 0. Okay. Now let's go on to another example. The second example is log 72.3. If I want to find the log of this number, then what is the value of characteristic here? Okay. So you see here the number is greater than 1. That is the first thing. First condition we have to check. Okay. 72 is greater than 1. 72.3 is greater than 1. So okay. It means my rule number 1 will apply. Okay. Now how many digits are there in the integral part? The integral part is 72. How many digits? 2 digits, and I have to just minus 1. So the Mantissa, the characteristic for this number is 1. Okay. Does it look easier now? Okay. Let's move on to the third example. Log of 0.0723. Now let us check our condition. Is it greater than 1 or less than 1? Okay, we see that it is less than 1. It means my rule 2 will apply here. What is my rule 2? Minus sign, okay. Number of zeros immediately after the decimal point. So my decimal point is here, and how many number of zeros are there? Okay, after it only one zero is there, okay. So I'll write 1, okay. Now what is the next thing I have to do? I have to just add 1 to it, okay. I have to add 1 to it, and my answer would be minus 2, which I can also write as 2 bar, okay. Now it means the characteristic of the log of this number is 2 bar, okay. So pretty simple, nothing difficult here. Just pay attention to these two rules and they're quite easy to apply. You won't find any difficulty here, okay. Now let's talk about the Mantissa. Mantissa, you find it with the help of the log table that is given to you, okay, and its value is always positive, okay. And in most of the aptitude exams that you appear for your entrance exams or placement tests, this won't be required to find with the help of a log table, okay. Now let us see how this information or how are the questions based, okay. One is this variety of questions that you will find, okay. Now there is some more to it. Let's see in the next slide. Question number 13. Find the number of digits in 4 to the power 10 multiplied by 6 to the power 10. This is another variety of question that you will find in this chapter. And if you look at this number 4 to the power 10 multiplied by 6 to the power 10, you will feel that the outcome is going to be a very big number, okay. And you might get scared. How will I count the number of digits? But trust me, this is a very easy question because it just needs you to apply whatever you have learned till now. The basics that you have learned will make this question very easy if you are able to apply them properly, okay. And there is some little extra information needed, which is here. The number of digits in a log is equal to the characteristic plus 1, okay. For now, just read this, understand this, and when we apply it in the question, you will understand it in a better way, okay. We have already seen what is characteristic and how to find it, okay. The next thing that you will require to solve this question will be the value of log 2 and log 3, okay. In this question, it is not given to you here. That is why I had said just try to remember these two basic values, because in most of the questions you will need these, and if there is anything else required, it will be given to you in the paper. But these are two very basic things, so try to remember them, okay. Now come to the question. The question is 4 to the power 10 multiplied by 6 to the power 10. I have to find the number of digits in this. So what I'll do is I'll simply take a log of this, okay. Now I know that 4 can be written as 2 square. So I'll write it as 2 square. It becomes to the power 10 multiplied by 6 can be written as 2 multiplied by 3. So this is 2 multiplied by 3 to the power 10. Okay. Now what is this? This is simply log of 2 to the power 20 multiplied by 2 to the power 10 multiplied by 3 to the power 10. This is how it becomes when you open it. Okay. And what is this? This is nothing but log 2 to the power 30 multiplied by 3 to the power 10. Now applying our basics that we have learnt and practiced till now, what is this? This is simply 30 log 2 plus 10 log 3, isn't it? We are given the value of log 2. So 30 multiplied by 0.3010 plus 10 multiplied by 0.4771. Okay. Now this comes out to be 9.03 plus 4.771. Okay. So this is what this is approximately 9.03 plus 4.771 is 13.801. Check this, you can check it too. Okay, so this is the value of log of the number. Okay, now what is the characteristic here? The characteristic here is, we know when we find the log of a number, the characteristic is the integral part. Okay, so this is 13 here. So 13 is the characteristic. This is the characteristic. Characteristic. Okay, I remember the spelling correctly. Okay, characteristic. Okay, now number of digits. So we have seen just now, number of digits is equal to characteristic, that is 13 plus 1, and that is nothing but 14. So the answer for this question is 14. Number of digits in 4 to the power 10 into 6 to the power 10 is 14. Okay, nothing difficult here. You just have to apply your basics. So wasn't it easy? Yes, pretty easy. You just take a look. If you are anywhere confused, just pause the video for a moment and take a good look. Okay, so guys, with this we come to the end of this video, and I sincerely hope that whatever we have learnt in this video is going to help you solve all the questions from this chapter. We are going to release a lot many new videos on aptitude, quantitative aptitude. If you want to receive them, make sure that you subscribe to the channel, and if you found today's video useful, make sure that you give it a thumbs up also. I'll see you very soon with a new video. Till then, bye bye. Take care.